Brunei Darussalam land size span around 5,765 square kilometers with a population of less than 500,000. Rice has always been one of the staple commodities that are subsidized by the government. Shortage of staple food production is one top issue that the government is addressing at the moment. With the unpredictable climate change, the country needs to step up in prioritizing food security and increase self-sufficiencies as food crises become increasingly severe. Thus, we need to mitigate the food supply problem by leveraging on the use of science, technology, and innovation. We can change how we grow rice through efficient and intensive smart farming. In general, paddy life cycle goes through 3 phases, namely vegetative phase, reproductive phase, and ripening stage. During the vegetative phase is the phase that water is needed the most. This is to protect the paddy from pests, diseases, weeds, snails from invading and feeding onto the paddy and affecting the yield. During the reproductive phase, the pinnacle starts to boost and heads to flowering. During the ripening phase, it is the mature stage where the paddy can be harvested 2 or 3 times a year, depending on its nature. Traditionally, rice paddy is known to be a water-intensive crop. By knowing when the water is needed the most, we are able to provide good water irrigation, which is significant to give sufficient amount of water to the respective paddy field depending on the phase. There are also different paddy life cycles depending on the rice varieties. The norm will have a life cycle of about 110 days from seeds until it is ready for harvesting. Good quality seeds, proper land leveling, proper soil treatment for acidic soil, efficient establishment of rice plants, efficient irrigation system, basic pest management, and harvesting with care are the main ingredients to a good yield. Brunei rely heavily on imports rice to meet the country's need. His Majesty's call self-sufficiency in rice production makes more emphasis to the need to increase the rice production yield even more. Gazetted areas for agriculture use are available within the 4 districts, but for paddy, this is mostly concentrated in Brunei Mora, where they are irrigated with water from Emang Dam. Emang Dam is a natural lake from high ground areas. There are 2 tanks with a holding tank having a capacity of 5,000 cubic meters each, and these 2 tanks give a total of 10,000 cubic meters. The water distribution works by pumping water daily from the Emang reservoir to the holding tanks, which is then distributed to Wasan and other fields via pipes. The main paddy producing area of Brunei Mora is in Wasan. With 2 planting seasons, these areas are managed by Kosika and MPP. From the interview session with our local farmers, the issues are the high-level soil acidity, poor irrigation especially during the dry season, and the climate change. One of the major problems faced is the inefficient irrigation system that leads to the lack of water supply to plots that are far away from the pipes. Distribution to individual plots is not consistent. The pressure becomes low as the water goes further away from the initial position, and sometimes it would not reach the end of the paddy field. That is why such problem arises. To address this inefficient irrigation is by means of adopting technology to help regulate the water issue in Paddy Plantation through ASEAN IVO 2018 project known as Smart Watering System.
The project members are from NECTEC Thailand, UCSY Myanmar, UTM Malaysia, and ICT Japan, DAA, and UTB from Brunei. The project meetings were held in Japan, site visits to Brunei and Myanmar to understand the requirements. The solution comes in the form of technology that is adopting the smart watering system and water gate to address the irrigation issue. By making use of the alternate wetting and drying AWD approach introduced by IRI studies in other countries has shown to conserve 25% of water. Prototypes of smart AWD and automated water gate were attempted through student projects, and through an ASEAN IVO 2018 project implementation, these prototypes were then developed into deployable solutions. The objective of this project is to implement and test a prototype of a smart watering system based on the concept of Mesh-Topological low-power wireless network platform. The prototype of the proposed platform consists of a control node, sensor nodes, and irrigation-valve-controller nodes. Also, this platform includes a gateway that relays collected data to a cloud database. The solutions consist of a weather station and sensor stations with respective sensor nodes that can capture important parameters such as weather parameters, water level in the field, soil moisture and temperature, and pH value to measure the acidic level of the water. The prototypes were improved since the deployed solutions will need to be able to stand the harsh environment. This was developed further by NECTEC Thailand. The equipment was assembled and tested in UTB CIE lab ready for deployment to the actual site. We set up one of our weather stations in Imang Dam area with the collected real-time data. Because of the security aspects of the sensor stations, we then opt to move the deployment to a new site, Institute Brunei Technical Education IBT Agro Wasan. It's 7.7 km away from Imang Dam.
The second weather station is deployed in IBT Agro Wasan while the sensor nodes on the paddy field. The platform function as follows. The sensor node collects data about environmental parameters such as soil moisture, temperature and precipitation and send them to the control node. The control node analyzes the received data together with the plant profile and send commands to the irrigation-valve-controller nodes, water gate, in order to water to plant. All collected data are relayed to the gateway to the cloud database. For prototype of water gate was not suitable enough in the harsh environment, hence a low-cost, low-power design was aimed.
Let's assume that the water from paddy field at the front is flowing to the paddy field or canal at the back of the water gate. Initially, water is flowing through the opening, with the water gate is floating. To pull the water gate, the controller turns on the power of inlet pump to pull the water from container into the water gate. Here, the frame of the water gate also functions as water container, with the inlet pump is attached. With the water flowing in, the water gate becomes heavier, blocking the opening and the water stops flowing. When the sensor sends signal that the water level at the field is too high, the controller will turn on the outlet pump. The water inside the water gate is pushed out back into the water container. Now, the water gate becomes lighter, so it floats, creating opening for the water from the paddy field to flow out.
Next is to analyze the collected data and redefine the project requirement. The water gate integration to the existing system will also be done together with monitoring of the dams to ensure no flood or drought issues during the two separate seasons. Users of the system will then be able to use the data from the weather station and the ground sensors to make a better decision in ensuring towards a smart watering system for paddy plantation.